Hello, good evening everybody. So as I was already introduced by Pekka, my name is Matti Kuittinen. I work in two instances. I work at Aalto University as an adjunct professor starting 4 days ago, and at the Ministry of the Environment as a senior specialist. So that blends the two professional loves of my life, policy making and teaching and academia. But today we're going to talk about something that has its roots not in architecture but actually in medicine. The phrase here, do no harm, is attributed to Hippocrates, the famous Greek father of modern medicine. And in his writing you can find this phrase, and he talks about that when a doctor is treating a patient, he or she shouldn't cause more problems than what the treatment is meant to solve. So we don't want to end up too often in a situation where the operation went great but the patient died. So that's normally considered to be one of the goals of medicine. But this principle, however, lends itself very well to other fields of life as well. For instance, in humanitarian work, of which I have a little experience, it's often used and often kept as a principle. So when the Western wealthy people go to a poor, underdeveloped country to help them to get over an earthquake or something, they shouldn't cause more problems than they're trying to solve. I was working in Haiti after the earthquake, and there were peacekeeping forces, UN peacekeeping forces from Nepal, and they of course kept peace, but at the same time, unfortunately, they brought in cholera, which is not typical of Haiti. So they tried to do good, but unfortunately they did something else as well. So the do no harm principle also lends itself to construction and architecture, and maybe today it's one of the key questions, at least from policymaker viewpoints, when we talk about construction. Because we use half of all global raw materials for building. During this century, there will be around 11 billion people living in buildings that are not yet built. And we can't keep on increasing the use of natural resources for construction on the same rate that we do today, because it's causing at least 1/3 of all global greenhouse gas emissions, and it's not tolerable. So we need to change the way. I suppose that many who are here today are architects as well as I am. And we've been trained to get our living by designing new buildings or planning new cities. And if we are to cut drastically down the emissions that are attributed to building sector, how are we about to do that while keeping on what we are taught to do, designing buildings? That is a very big and fundamental question. And I hope that we can discuss about it today. So to put that in formula, we can talk about increasing or at least maintaining the quality of a building while cutting down the harmful impacts of the building's life cycle. So this is pretty self-evident that this is the way to go. However, the task ahead here in going down with the harmful impacts is very large and very challenging. So we can take a look at that from the viewpoint of resource efficiency using a term called decoupling. Now there are two ways of decoupling things. The first one is called relative decoupling, and it's used in resource efficiency to describe that ideally the gross domestic product should increase while the environmental impacts or harms are increasing, but not in a steep curve as the gross domestic product. So this is called relative decoupling. This here, absolute decoupling, is much more favorable. It describes that the GDP goes up while the environmental impact goes down. So this is where we are aiming at, and this is where all the societies should aim towards. Then if we take a look at this from the viewpoint of greenhouse gas emissions, it's been suggested that we should cut down the global greenhouse gas emissions 50% every 10 years in order to avoid very dangerous and very, very expensive climate change. And this is interesting when we try to see that how can we make this happen in the buildings that we are designing and building. And this leads us to ask the question, that how would architecture look like if we would need to halve greenhouse gas emissions every decade. Now think about the chair in which you are sitting. Think about that if the same chair designed in 10 years would have to be done with half of the materials that it has now. What sort of chair would that be if there would still be a need for a chair? Now that's of course rather superficial like thing to say, but anyway, that explains maybe something of the challenge that we have ahead. So it's a question of architecture and it's a question of process. How can we make the buildings work and maintain much of their functions while creating much less environmental problems? Well, one thing is for sure, we must get away from the linear thinking that buildings are just consuming energy and materials over the life cycle, and we need to change into a circular thinking, especially in the construction sector, where the material flows that are put into the built environment are again reused and recycled, either into new construction products or at least into energy that is fed into the system and sustains the built environment. But to bring more perspective, I'd like to take you to a case study. It's Alan's and Lisa's wonderful school. It's a very nice building. And I had the privilege of getting full access to the building information model and all the material, bills of materials of this building. And together with my colleague at Aalto University, we made a calculation exercise. And we tried to figure out that how large is the carbon footprint of the building and its site. And then we wanted to know if it would be possible to reduce that without touching the architecture and the geometry of the building, of course. And then we want to see also that how large are the carbon storages and sinks around the building. So now, unfortunately, we are going to the boring part of the presentation in which I'll be showing graphs and figures, but let's hope that you can tolerate that while after having seen so much of the eye candy from Alan's previous presentation. So let the boredom begin. Here is the share of emissions from the building over a 50-year life cycle. Now, less than half of the emissions come from the operative use of energy, from the heating of the building and for the electricity, and over half come from the production of construction materials, construction work, and so forth. So the balance has already shifted from use of energy to these so-called embodied emissions. To explain that a bit more, I'm using this sort of graph. You saw that on a much more eye-friendly format in Alan's presentation. Everything that's on the right-hand side here on orange and red are emissions, so these are bad things, and the green ones here on the left-hand side, these are good things. So here we have all the parts of the building, and here we have how much emissions are caused from these building parts. Two interesting things. First of all, electrical elements, mostly solar PV panels, are the single biggest source of emissions in this building. And that's interesting because today we are hearing that, yeah, we should load our buildings with solar PVs and we should cover all the possible parts in cities with these. But we should think about also the principle of do no harm in this instance. And then the second interesting thing is that the site and crown works, these seem to cause relatively much emissions, although there is also the potential for sequestering carbon on the site. And now let's take a bit more detailed look about these. So first, if we take a look at the site, as Alan described, there used to be a site without any buildings, some trees standing there, and then there was some soil removed, some new soil and gravel brought in, and some asphalt roads done, and some concrete paving done, and the building was built. And while this was done, there were lots of emissions, mostly from the making of asphalt for the roads, but also from concrete paving and plastic pipes and so forth. And in the graphs on the following slides, I'm going to show you three things. First of all, the emissions, then how much carbon was either stored or sequestered, and what could have been done otherwise. What could we avoid if we chose a different approach? So we can see that if we just look at the site, it's the asphalt road and concrete paving that cause most of the emissions, but luckily the soils of the site in this building, while the building is being operated for 50 years, there are herbaceous plants, there are grasses, there are trees growing, and all these natural processes or ecosystem services, they accumulate soil, carbon from the atmosphere into the soils. And that's actually pretty much, it's actually more than what the production of asphalt causes. So lesson number one, we shouldn't underestimate the role of ecosystem services in our building projects. And this is something that is very poorly understood, especially in the urban context, unfortunately. Then, second thing, foundations and ground floor slab. Here we can see that most of the emissions are caused from the concrete used for these building parts. There is very little carbon to be sequestered, but if we would have used greener cement mix in which we could use cement substitutes such as fly ash or blast furnace slag up to 25 or even 50% of the amount of cement, we could cut the emissions from the use of concrete into half. And that's something that this is a big number. We should aim towards this. And in the end of the presentation, we will see if this is truly enough, if we would need to cut the emissions half every decade. Then let's take a look at the structural frame of the building. Here, most of the structure is made from wood, CLT. There are some insulation materials and very little amount of steel parts. But you can see that these cause very, very little amount of greenhouse gas emissions, whereas there is huge carbon storage in these materials. So if you could account this as a benefit, you can see that this actually has a positive impact. Then if we look at internal dividers in the building, and these things are something that you typically need to replace or at least repair during the use of the building. So that's why the materials make a difference. If we look at these, we can see that there are some emissions from the production of gypsum boards or CLT for the walls, but there are also lots of carbon stored in both wooden frames of the intermediate internal dividers and CLT materials. And if you want to be really nerd in trying to tweak your carbon footprint to as small as possible, then you could speculate on changing old gypsum boards into wood panels. But then again, you need to realize that in a typical construction project, you have other aspects than just the carbon footprint. There are fire safety, there's acoustics, and there is also the price. So gypsum board today is positioned so well in the cost optimum of construction materials that it's really hard to defeat in the construction markets. Then finally, this building, even though it's an old building, it's lots of building services, electric cords, ventilation, perhaps cables and ducts. And so does this beautiful Common Ground High School in New Haven. And the interesting thing is when we calculate all these and sum it up, that shows a remarkable impact on the carbon footprint, especially the solar panels. The impact of making these is huge. However, there are good news. There are so many ways of making solar panels. These are made from monocrystalline PVs, which is one of the ways of making solar panels. It's the most common today, and it has the best price to kilowatt-hour ratio today. However, if they would use thin film solar panels, we could cut this emission into half while keeping roughly the same level of renewable energy sequestered from the roof of the building. So I think here architects and engineers and designers should pay attention to what are the options of harvesting renewable energy in the building, because that can really lead to making harm or making no harm in the building. But still, if we are using these solar PV panels, the monocrystalline panels, the emission savings with these are huge, nevertheless, of the emissions that they are causing in their production phase. Now, depending on what sort of scenario we are imagining for the electricity's carbon footprint in this area, using solar PVs in the building can save from 370 to almost 1,000 tons of CO2, because you didn't have to purchase electricity from the grid. That has a certain carbon footprint in this area. So even though they had a big carbon footprint, that was an investment worth making. Then if we sum up all the mitigation potential that we have in this building, what could we have done otherwise? It seems that greener solar panels, this is the greatest thing that you could have done otherwise. and greener cement mix, obviously. And then if you switch gypsum boards into wood, that has an impact, not that large, but it has an impact. And if you could use recycled asphalt on the side, that would also make some difference. But the big gains are here. These are the low-hanging fruits that we should, in the next projects, and maybe you are also already taking these into account. Oh yeah, that's great to hear. So these mitigation potential, all summed up, is some 1/5 of all the emissions that are caused when the building parts were manufactured. Now that sounds like a big number, but unfortunately when we scale that up to the life cycle emissions of the building, it's only 4% of these emissions. And this leads us to ask the critical question that what if the building would have to be designed with half of the carbon footprint? How could we reach that? The good news, however, is that most of the emissions are a consequence of direct design choices. And those of us who work as designers or construction managers, we have a great potential and a great opportunity of influencing these emissions. So we truly can be the good guys in this battle towards climate change. Now, to sum it up, where is the ratio between the quality and the harmful impacts? Are the harmful ones winning? We can say that, of course, there is lots of quality in the architecture and function. There's lots of environmental quality in the storage of carbon and uptaking of that on the site. And there's lots of quality in the energy efficiency and use of renewable energy. However, we have life cycle emissions from the construction, and we have emissions from the land use change. It used to be, well, relatively close to natural state, at least there were trees growing. So there is a change of the land use and land occupation. Now, let's get to this question. If we compare the emissions, the harms that the building is causing to the good things, the sequestered and stored carbon, we can see that it's actually, this is half of the embodied emissions. But still, even though this building, up to in my opinion, is a very high quality building, it has very good technology, it has very wise design choices, still, it's not doing that well. And this is not a fault of a designer. This is something for the whole construction sector to tackle. Because it's impossible for an architect to make a building that's a saint if there are no raw materials or no products or processes for making that happen. It doesn't matter how beautiful dreams you are putting on the paper. It's the construction process and all the procurement decisions along it that either make it or take it. But the interesting thing is if this is like the state-of-the-art, excellent wooden school in USA today, in the 2020s, how could we make it happen in 2030s if we would need to cut down the emissions into half, into something like this, or 2040s, or 2050s? Let's imagine that we could use just zero carbon footprint electricity for the building. We could have, let's say, wind power or something that would cut this off totally. So we would be left only with the embodied emissions. So if that would happen, then we would be fit for 2030s. But then the real trick is to get to 2040s. And if we assess the building that we can cut up to 20% of the emissions of the production phase of the building by changing the materials and making more sustainable choices, it's still a huge task to reach this, or even this. And without touching the architecture or the geometry or the functionality of the building, it seems impossible. And that for designers is a really big question, that how can we satisfy the user needs, maybe with much less space, or maybe without building anything, maybe by occupying an existing empty space somewhere and trying to make that fit to the purpose of the user. I'm working at the moment with the revision of landscape and the construction regulation in Finland, and somebody from the stakeholder group asked the question that should we make that sort of proposal that if you want to build something new, you should have first figured out if there are any existing buildings. So there would be a ban of building anything unless you cannot show that there are no existing buildings into which that function could be placed. And that's a big thing to ask. But then again, if we were to reach this, how is that ever possible? Of course we can say that, okay, it's not, construction sector doesn't have to reach these things, the other sectors will do it. What other sectors? There is no way that the transport sector could go negative in its emissions. You cannot think that, or maybe somebody can figure out an airplane that's sucking CO2 from the atmosphere while it's flying. Or maybe you can figure out a food sector that's negative in terms of carbon emissions. But I mean that where is that other sector? And if there is another sector that is fully carbon negative, how much do we assume that would be the cost of compensating emissions for the sake of making buildings? And what would be the impact of the construction prices? And again, to living costs in cities. These are very big and fundamental questions that are not yet clear. But let's get to this. We should do no harm. We should think about these things while we are designing buildings. In my opinion, we should try to stuff as much carbon from the atmosphere to the wooden or bio-based parts of buildings while we design them. That seems to be one of the best options for making new buildings in the future. At the same time, we should make sure that we maintain the natural habitats in the state in which they can sequester carbon from the atmosphere, because this is by far the most easiest and cheapest way of removing carbon from the atmosphere, putting that into growing forest. Now, I have spent my time, and I think that maybe now it's a good time to maybe continue discussion with all you. Thank you very much.
Sometimes these lectures about environmental impacts turn to doomsday, but you brought a lot of good news. But what is your opinion? Is there more bad news or good news?
I fear that we have a huge task ahead of us, as Matti has identified, and working as a practitioner, as well as someone who tries to think outside of practice. The guys I work with on construction sites their bottom line, their bottom dollar is the primary interest. In the American building industry, which produces a lot of building, how can I put it? The craft of building is no longer a priority. And the economic instrumentality of building has become the priority. And so that scares me, honestly. But then again, I met Pekka and Matti, I don't know, 8, 9 years ago. And in that time, the changes that I've seen in the wood industry in the US are significant. And what's more, it's captured the interests and excitement of builders, developers, architects, and most importantly, my students. And I think that's promising. And then what we talked about today at this conference is that there's a problem of people unlearning habits, conventions, and it's hard enough for me to, I don't know, drive slower, eat less, you know, those are hard. But when you have a gigantic economic system, a political power structure, cultural biases, those are hard to shift. And so I think our challenge is what's being asked today at Finlandia Hall, which is how do we rethink our activities as human beings, which is exactly what Matti's saying. I'm not going to say I'm pessimistic because despite my doom and gloom personality, I have hope that we'll be able to solve it, but I think Matti has very succinctly described the challenges of that. So I'll let you take it.
Yeah, of course, I'm very optimistic since, after all, We created this problem, so I suppose that we are able to solve it. So it's not a force of nature that made this. It's not an alien species that invaded the Earth. It's us. So we can do it. I don't think that's impossible at all. We just need to shift the mindset. And I think that if you want to look at this from the positive perspective, I think that the shift to circular economy and sustainable lifestyle, it's going to happen anyway. But the tricky thing is that there are two paths that lead there. There is the path that assumes that we can quickly change our policies and our behavior so that we can do the shift in a controlled manner. And we can all be happy and prosperous even. And then there is the path in which we see that the negative impacts of changing climate and the negative impacts of the Anthropocene, they become intolerable to human nature, which may lead, as we already see today, into rise of political turmoil, populism perhaps, which weakens the decision-making capacity of our societies. And we end up in struggle for resources on the planet with more people on it. But also in this scenario, we will end up in circular economy and sustainable lifestyle, but the problem is that we are going to hit the wall before that happens. And that's going to hurt economically, socially, and on human level. So either way, I believe that that's the future, but it would be so much nicer if we could choose path number one.
By the way, to me this was a perfect combination of research and design practice, and emphasized the meaning of the lifelong learning. And thanks, Alan, for volunteering to be a guinea pig on that Matti study, which didn't always look good, but next time it will be, of course, much better. How did you feel about that?
Thank you, Alan and Matti, for the great lectures. I would have a question, because let's say that as architects, how much we can do. So my question would be, how do you, watching your projects, I was thinking about the symbolic meaning of them. Obviously you have made your breakthrough in the US, and your school is like one of the, well, it seems we are looking at it right here across the Atlantic. And so what would you think about this symbolic meaning and importance of your work? Do you see any importance on those things?
Is this working? Yeah. Thanks, Antti. I guess I would say I'd quote the former dean of the school that I teach in now, Paul Rudolph, who said he never talks about design with his clients. Obviously, there's an enormous interest in the cultural meaning, impact, symbolism, significations of architecture. And I think that gets to a point that Matti has made really articulately in papers he's written, which is decoupling is the separation of quality from harmful impact. But part of the quality that I think you're advocating, if I can speak for you, is that the architectural, the symbolic character, the meaning of the built environment is as important as its environmental, its lack of environmental impact. It is interesting that I think I used to talk more about our work and think more about our work as an art project, an art practice, a cultural practice. Now I think I've become a little more of a, I think really hard about what I'm doing wrong, about the doing no harm. And so I tend to talk about it that way. But of course, as you know, in your work, all of these issues of how people live there and how their children play and what the shapes of the buildings that we make, whatever they are how they're enjoyed. And those are deep in our work. That's a big part of it. Otherwise, we just build ticky-tacky boxes all over the place. And sometimes end up having to anyway. I've done my share. So I think that's a really important question, because I think the way, for me, what's meaningful about hearing Matti talk about the work and having basically been undressed architecturally by him, is that the stakes are high environmentally, but the stakes are high culturally. We can't debase our built environment aesthetically. We can't debase it in terms of human experience, in terms of safety, in terms of all the things that we think about that give meaning to architecture, because then environmental low-impact work creates another kind of environmental depredation. And so I think that's, I don't want to diminish that side. I mean, I hope you can see from the work that I've done, the small projects that we've done, that we care a lot about that. But I think I have to front load some concerns for my kids and their kids and my friends, because I just think I want people to know that it's not just a discussion of culture, and that's important.
Without touching the architecture, should we touch the architecture?
Well, you should ask an architect, perhaps. But I think that it's question about how much space do we need to fulfill our functions, and could we be wiser in that? Pekka, we've been teaching together at the Wood program for many years, and I remember when I started as your assistant many years ago. Yes, yeah, but I'm having a point here. And the point is that I remember when the first Japanese students came in, and they started to make their sketches and examples of how you could redesign a sauna or something else. And I was like, wow, how can you really stuff so many functions into such a small space and layer them on top of each other and make a multifunctional space? That was a really eye-opener for me of seeing the richness in different design cultures and design contexts. So I'm very confident that we have not yet reached the bottom in the tank of architectural possibilities. There are so much more to come.
So that brings us back to your question, which is that I think the thing that I'm most thrilled about is the idea that the invention, architectural invention, that will be driven by resource scarcity. That seems to me like a really, that's what my students are excited about. That they can go to work to solve problems that are more than the marginalized aesthetic concerns of a certain class of people, but that they actually are having an impact. And that has the cultural meaning that you raise and the signification that you raise. I have been working in Japan, and I know that we can make buildings smaller. I think we can make them simpler. They can weigh less. They can be simpler across the supply chain, fewer steps. So all of these things, I think, are part of that. And I revel in the new architecture that will produce. So I would even say, I think they should change. I want them to change. I'm excited about being part of that process.
By the way, just for information, we have still 4 lecture sessions left, and not all the lecturers are not my friends.
So you are inviting some of your enemies as well.
I will keep on asking a stupid question if you don't do it. Matti, is something to add?
Yeah, just a small addition, if I may. I've been reading about, from the behavioral psychologist, papers about minimalism or voluntary simplicity. And that's actually rather interesting, because that minimalism is one of the trends in architecture, even quite often it's fashionable. But it's an interesting question that since this is a trend among well-educated middle class or upper middle class Western people, they want to live a more simple life in a beautifully designed, very empty-looking apartment. Could that be one of the paths that we could use as a fuel for architecture of getting more with less materials?
Finally finding the answer for the question of whether less or more. Fred, you have something in your mind.
We have a saying in English that when the going gets tough, the tough get going. And I'm beginning sitting here and listening to you guys who obviously put a lot of time, a lot of care into what you're doing, and you're extremely well motivated. But my question to you is, we belong to a very, very small minority of people on this planet. That's one problem. Second problem is, we need to accelerate the changes you've been talking about. And how do we actually do it when 70% of the world's population are hell-bent on becoming as big, if not bigger, consumers than we've been? And I think I'm not saying architects, the contribution we're going to make is fairly minimal at the end of the day. But how do you see as educators, as let's say middle-class do-gooders, how do you see this process accelerating? Because we need to accelerate it, and really, really fast.
I think this is one of the quick questions, of course, and one of the answers that I've come across is economy. Today we are seeing a boom of green bonds and green financing, luckily, and that may tick the box that reads greed, and that's one of the best motivators for man, to get more money. And luckily investors are coming up with more and more mechanisms for sustainable financing and green bonds. And these are becoming very popular also in the construction, infrastructure and energy sectors. So it might actually be that the business is solving part of this problem. It's getting more profitable to invest in green projects. You get much more revenue from them. It's not, of course, going to solve everything, but that's, I hope, part of the problem, because it's money that makes the world go round, and I hope that it's going to make it turn around into a better direction. Then you said that we are a marginal part of people. We are architects or something. We have something to do with construction, and we are from Western country, well educated ones. But I think that it's our moral attitude to do something for two reasons. First of all, 50% of global raw materials go through our fingers or through our building information models. Secondly, average free carbon footprint is 10.4 tons per year. It's over double of the world average, which is many times too big. That would have to be smaller as well. And maybe a third point would be that Finland, as has been repeated often, and while the new government has been getting all its skis into the same direction, Finland can be a bigger player in the global sector than what it's actually its size. So we could at least try making a good impact.
We will give you practical tools, did we, or did we cheat you? What if we did? Is it still secret that you're publishing the online education package about these issues, or now I say it?
Yes, tomorrow we launched the Decarbonized Design website, which has several components, open source learning materials, wonderful lectures by Matti, which you can download, curriculum materials for graduate educators in engineering, design, building. We're working on wrapping up a book, which has been like giving birth to a small cow. But I think it's really focusing on all the issues that we talked about today, and it's been a really great international transatlantic collaboration, not only for Pekka and Matti and me and our colleague Andy back in my office, but also all of our students from Aalto University and Yale who have been involved in this process too. And they'll be presenting tomorrow at the World Circular Economic Forum in their work. So I have learned a lot about this from this lecture, and I've been working on this with you for a while. So I hope you all will take advantage of those materials and forgive us the sins of website operability if it's not working right away, but we're working on that now. So, yeah. I guess that was the launch, pre-launch launch.
Sorry about that. We could go on for ages, but I have bad news. We have to throw me out, but luckily Reetta has good news for you.
We would like to invite everybody outdoors for a little snack, healthy snack, so we can discuss in this sort of more leisurely-like environment outdoors. We don't have a forest in the city, but we would like to guide you through our back door to the backyard. So let's enjoy. You're all welcome.